First, we're going to just talk about tangent again. So tangent is a line that intersects the circle in just one location. So what line intersects the circle just once? Line TX. In case you forgot how to name a line, you need to use two letters on the line, unless they ever just have a little lowercase letter. So line TX is the tangent line. It just intersects the circle once.
That stands for Texas.
Yeah.
Okay. And the point of tangency. The point of tangency is where it touches the circle. What point does it touch the circle at?
T.
T. So that's its point of tangency. Thank you. That's so cute. I have to show everybody. So cute. Thank you, Minnie. I appreciate that.
Good job.
I'm going to eat those eyeballs later.
Okay, that's
Don't judge. Okay, point in the interior. So what's a point in the interior of this circle?
I.
Yeah, they both are, but I would say I, because I would call P actually the center of the circle. And what's a point in the exterior?
Oh, X.
Okay, so just practicing a little terminology. Okay, here we go with our first theorem. This says if we have a line tangent to a circle, then it's going to be perpendicular to the radius drawn at the point of tangency. Okay, so in this problem here, AB would be the tangent line because it only would touch the circle once, especially if I extended it. So that's the tangent line, and it says that where it connects to the radius at that point of tangency, it's perpendicular.
Would you do A squared plus B squared equals C squared?
I will here in a minute.
Yeah.
So the theorem is just letting you know when a right angle happens. A right angle happens whenever we have a tangent segment meet a radius. So wherever a tangent segment meets a radius, it forms a 90-degree angle there. Okay, so yes, I'm going to figure out that whole length right there. What would the A squared plus B squared?
5 squared equals C squared.
Okay, so 12 squared plus 5 squared. Sure, let's you see. Okay, tell me what you get. 12 squared plus 5 squared equals C squared. I want to know C's final answer.
13.
13, right? You'd have 144 plus 25, which is 169. So C squared is 169, so C would be 13. Did you not say 13 squared?
He did. 13 squared.
Okay, but it's just 13.
What is C squared?
Well, yeah, C squared would be 13 squared, so C would be 13.
Sorry, I was just saying 13 squared.
No, it's okay. I'm just saying. Okay, and then I need to know how much X is. Does anybody know without me saying?
6.5.
8.
It's 8. Let's look.
Oh, yeah.
This guy has a special name. What's he called? A radius. This guy has a special name. What's it called?
A radii.
A radius. So if this radius is 5 and this radius is 5, then X would be 8. Because 5 plus 8 makes 13. So don't let the radii fool you. One radius is the same as another radius. You just have to pay attention to where the radii are in the circle. Okay, this next theorem, super easy. This says if we have two segments from the same exterior point tangent to a circle, then those segments are congruent. Okay, so if they come from the same exterior point and they're tangent to a circle, then those segments are congruent. So this is a tangent segment. It comes out to this exterior point. This is a tangent segment. It comes out to that same exterior point, so that means that these two segments are congruent. Pretty easy. What's your equation? 2x minus 3 equals 27. Calculate it. Boop, 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 boop.
15.
There we go.
Can you make that noise again?
Of course I can.
Let's hear it.
Boop, 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 boop.
Sound like that
No,
robot.
the only thing I think about when you do that is wind blow.
Okay.
You don't know what wind blow
That's not such a bad thing, right? That's a great movie.
Greatest movie ever.
No, I'm down with that.
Bill and Ted, actually, Bill and Ted's excellent.
I want to say
Greatest 80s movie ever.
No, Bill and Ted's excellent adventure.
Okay, here we go. This says when circles are inscribed in polygons, the polygons are said to be circumscribed polygons. I know that seems crazy. But this circle here is inscribed inside of this triangle because it fits real nice and neat. All of the points are actually on the triangle, so this is said to be a circumscribed circle. Okay. Do you agree that this would be a tangent piece right here? Does it just touch the circle once?
Yes.
Is this a tangent piece right here?
Yes.
Okay, we just learned in that last theorem, if two tangent pieces come to the same exterior angle, then those tangent pieces are congruent. Okay, looking down here. This is a tangent piece because it touches the circle once. This is a tangent piece because it touches the circle once. They both come out to the same exterior point, so this length is congruent to this length. Okay, over here. This is another tangent segment. It touches the circle once. This is another tangent segment. It touches the circle once. They both come out to the same exterior point, so those two are congruent.
True.
Okay, so now let's look at what they said. It says that TK is 3. TK is 3. So what else do you know? You know TL is 3. Okay, then it tells us that WM is 9.5. So WM is 9.5. So that means WK is 9.5. Okay, and then did it ever tell me how long LR or MR were? No, but it did tell me that the perimeter is 50. How do you find perimeter? Add up all the sides. This plus this plus this plus this plus this plus this equals 50. Since I don't know how long this is, I'm just going to call it X. So how long would this one be? X. So my equation would be 3 plus 3 plus 9.5 plus 9.5 plus X equals 50. Let's do a little combining like terms. What's 3 plus 3 plus 9.5 plus 9.5?
25.
9 plus 9 equals 18.
It's 25, right?
It is 25.
9.5 plus 9.5 is 19. Plus another 6 is 25. Okay, plus X plus X?
2x.
Okay, so instead of just me writing 3 plus 3 plus 9.5 plus 9.5 plus X equals 50, I just decided to combine like terms. Are you okay with that?
Yeah.
Okay, solve for X. Boop, 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 boop.
That would be 18.
It should be 12.5. When I subtract the 25, I get 2x is 25. And then when I divide by 2, that's okay. And then I want to know how long TR is. So I'm going to put 12.5 right there. How long would segment TR be?
15.5.
15.5. Because I would take the 12.5 plus the 3. Adam, can you please stop talking?
Yeah.
Thanks. Super. Okay, next picture. Let's talk about a few things that we've already learned. Is this a tangent line right here?
Yes.
It touches the circle once. Okay, we learned in the very first theorem that if we have a tangent piece that meets a radius, what's it form when the tangent piece meets the radius? It forms a right triangle, so that's a 90-degree angle. Okay, let's talk about this tangent piece. Does it meet a radius too? And where it meets that radius, it forms a 90-degree angle. Okay, so let's look at what else we know. We know OA is 12. That's just kind of hard to put in that picture, but I know that this whole piece here is 12. I know OB is 6. Let's focus about OB for a second. OB is special. What's OB? It's a radius. Well, it's just one, so it's a radius.
But there's 3 radiuses.
Well, yes, these 3 together would be the radii, but OB is a radius. There's more. Where else? Where's another radius? OE is a radius, so how long is it? 6. Where else? OC is a radius, so it's 6. OD or DO, that's a radius, it's 6. Okay, next thing I'm told is that the measure of angle BAC is 60. BAC. This whole angle right here is 60. Any guesses what each of those might be? They are each 30. Do you want me to explain why I know that?
No.
Okay. Okay. Well, I could talk about this triangle. This triangle is actually congruent to this triangle, so I know those angles are the same. That's why I know. And if the whole thing's 60, they're each 30. Okay, so I want to find the following. Okay, A, how long is OC? 6. ED, how long is ED? 12. Beautiful. Okay, I'm going to skip AB for a second. I'm going to skip AC. Let's go to E. What's the measure of angle BAO?
30.
30 degrees. What's the measure of angle OCA?
30.
90.
90.
90, right. OCA, that guy, 90.
Yeah.
What's the measure of angle AOC?
60.
AOC is 60. How'd you guys know that that was 60?
So it's 69 and triangle.
Oh, you guys are amazing. That one's 60. So would this one right here be 62?
Yes.
It is. Okay. How long is EA?
6.
How'd you know it was 6?
I just did it in my head.
O to A is 12.
Good. O to A is 12, and if that piece is 6, then EA would be 6. Yay! Okay, now let's look at AB. I'm going to focus in on this triangle for a second. I want to know how long AB is. I'm going to put an X there. I have choices. What could you do? If I wanted to find X, I could do Pythagorean theorem, or I could do the 30, 60, 90.
Yeah.
What do you want to do? Pythagorean theorem or the 30, 60, 90?
30, 60, 90.
Oh my God, I didn't think you'd vote for that. Okay. Across from the 30, you label with a what?
X squared. 3.
Just X. Across from the 30, you label with an X. Because there's a number already there, I'm going to put equals X. Across from the 60, you label with what? X square root of 3. And then across from the 90 is 2x. Okay, which I don't even need to know. As long as I know x, this is easy. See how x is 6? So if x is 6, what's that x right there?
6 square root of 3.
So 6 square root of 3, and that's your length. The length of AB is 6 square root of 3. Actually, much faster than the Pythagorean theorem. If AB has a length of 6 square root of 3, do you know what AC has a length of? 6 square root of 3. And I know that those are congruent because we learned in the second theorem that if you have two tangent segments that come out to the same exterior point, that those two segments are congruent.
Wait, what was AC the same?
Yeah, AC is the same. Since these are both tangent segments and they come out to the same exterior point, then I know that those segments are congruent. Okay, we're running out of time, and I know you don't want homework, but you're going to get some. Couple things I want to talk about here. What are some things you know, just looking at this picture? Tell me some things you know, based off of what we've learned today.
AB equal AD.
AB equals AD. Two tangent segments that come out to the exterior, they are congruent. So what equation could you set up right there?
2x minus 13 equals 41. Equals 48.
Okay. I could go ahead and I could work that, but just we're running out of time. What else do you know about this picture? Something else we learned today. Yeah.
C and CD are radius.
Yeah. B, C, and C, D are radii, but it's mainly that. That's 90 degrees where the tangent and the radius meet, and that's 90 degrees where the tangent and the radius meet. Okay, and then we could go from there. Okay, so your assignment looks kind of confusing, so we're going to cross some stuff off. Okay, so this is page 20. Well, there's several problems to each problem, and I just don't want you to have to mess with it. So we're going to cross off the back part of the first problem. We're going to cross off the front part of the first problem. We're going to cross off the back part of the third problem. We're going to cross off the front part of the fourth problem. Everybody with me?
Yep.
Flip. Let's just keep doing that. So on 5, we'll cross off the back part. And on 6, let's cross off the front part. And we're going to cross off 7 through 10. Happy Valentine's Day.
Can you show the first
Have a great day.
Thank you.
I wrote you
Back, front. And then I just continued that.
I wrote you a beautiful note.
I saw it. Thank you.
I really hope she did. That'd be awkward.